mathematicians! In today's video, we are going to look at exponential equations and specifically focusing on the hidden quadratic. So we're going to need to become familiar with recognizing when we have a difference of squares and when we have a quadratic trinomial in exponent form. So recall up here, this is what a difference of squares looks like. So we have a squared minus b squared factors to a plus b, a minus b. Now we might also be given a trinomial instead, which has the form ax squared plus bx plus c. So let's take a look at the first two examples on the page here. In the example on the left, example A, 9x squared minus 36 is a difference of squares. We'll see that 9 and 36 are both perfect squares. So in fact, this factors to 3 to the power of x minus 6 times 3 to the power of x plus 6. And you can always go back and check your work by expanding these two binomial expressions. So let's do one to check. So we're going to multiply the 3 to the power of x with the 3 to the power of x. That gives us 9 to the power of x. Then the 3 to the power of x times 6 gives us 6 times 3 to the power of x. Then we have the minus 6 times 3 to the power of x, which is minus 6 times 3 to the power of x. And finally, we have the minus 6 times positive 6, which gives us minus 36. We can see the middle terms cancel out to become 0, leaving us with 9 to the power of x minus 36 as our final answer. Okay, let's try the next question. 5 to the power of 2x minus 3 times 5 to the power of x plus 2. So the thing to notice here is that we have two terms that have exponents of base 5. They have the same base. We can make our lives a little bit easier by actually rewriting 5 to the power of x as a. So we can say let a equal 5 to the power of x. So that means that my expression here, so therefore 5 to the power of 2x minus 3 times 5 to the power of x plus 2 becomes a squared minus 3a plus 2. And now we can see we have a quadratic trinomial that is factorable. We need two numbers that multiply to make positive 2 and add to make minus 3. So that's going to be negative 2 and minus 1. And don't forget to replace a with 5 to the power of x in our final answer. Okay, and once we have that, we are done. We have factored these two expressions. All right, now is your turn. So take a few minutes, pause the video, and try these questions on your own. All right, let's check our work. So 81 minus 4 to the power of n is a difference of squares that factors to 9 minus 2 to the power of n and 9 plus 2 to the power of n. B is also a difference of squares, which factors to 5 to the power of x minus 6 to the power of x times 5 to the power of x plus 6 to the power of x. C, another difference of squares. This factors to 9 minus 4 to the power of n times 9 plus 4 to the power of n. All right, these next two are a little bit trickier. So what we can do for A is let A equal 2 to the power of x. So that's my repeated base that I'm seeing here. And so that expression becomes a squared plus 3a minus 28. This turns out to factor as a plus 7 times a minus 4. And of course, we need to rewrite the expression now, replacing a with 2 to the power of x. And it is done. Okay, the second question here, B. Notice that we don't have like bases, but we can rewrite 9 to the power of x as 3 to the power of 2x. And now we can see more easily our hidden quadratic. Except, notice one other thing. We need to break apart this middle term first. So let's rewrite this expression slightly. I'm going to rewrite it as 3 to the power of x squared plus 3 to the power of x times 3 to the power of 2 plus 8. And now when I make my let statement, I can let a equal 3 to the power of x, and I replace all my instances of 3 to the power of x with a, which leaves me with a squared plus 9a plus 8, and that factors to a plus 8 times a plus 1. Don't forget to replace a with 3 to the power of x. And now all my expressions are factored. Thanks for watching, and please hit like and subscribe for more math help in the future. See you next time.